And here's another example of how we work with polarizers. Now here's an interesting example. We now have 3 polarizers, and notice that the first one is perpendicular. The second one is at a 45-degree angle relative to the first one, and the third one is at a 45-degree angle relative to the second one, which means that the third one is perpendicular to the first one. And the first inclination is, if we look at the previous example, if we had one that was perpendicular to the first one, we'd expect that no light intensity would make it through altogether. But that's only if there's 2 of them, one that's vertical and the other one that is sideways, so perpendicular to the first one. But if you put 3 of them like that, something very interesting happens. And let's illustrate that by working out the problem. First of all, we can say that I sub 1 is equal to 1/2 I sub 0. So after light passes through the first polarizer, you have lost half of your initial intensity. Now let's look at what the intensity would be when we get through the second polarizer. Here we can say that I sub 2 is equal to I sub 1 times the cosine of theta sub 1 squared. And in this case, that is I sub 1 times the cosine squared of 45 degrees. And that's equal to I sub 1 times, and the cosine of 45 degrees is 0.707. If we square that, that's equal to 0.5. Which means it's 0.5 times I sub 1. And of course, since I sub 1 is equal to half of I sub 0, that would be equal to 0.5 times 0.5 times I sub 0, which means you're now down to 0.25, or a quarter of its initial intensity. So the light coming past the second polarizer will now only be 1/4 of the original intensity. So what happens now when it passes through the third polarizer? Well, what we can say here is that I sub 3 is equal to I sub 2 times the cosine squared of the second angle. The second angle also being 45 degrees, so this is equal to I sub 2 times the cosine squared of 45 degrees. And of course, the cosine of 45 degrees is 0.707. Square that, you get 0.5. So that is equal to 0.5 times I2. And there it gives us, that's what I3 is equal to. And then, when you plug in what I2 is equal to, which is equal to a quarter of I sub 0, you see that I sub 3 is equal to 0.5 times 0.25 times I sub 0, which means that I sub 3 is equal to 0.125 times I sub 0, not 0, but 12.5% of its original intensity. This is equal to 12.5% of I sub 0. So when we put more than 2 polarizers, one behind each other, you can then see that the intensity of the light going to the last polarizer is not 0, but something bigger than 0, which is quite interesting. And that's how you do a problem like that. I have now one more example if you want to stay tuned for that one.